All right, here's that page 2 for the extra credit, the Excel sheet. Went through this once before, but it was kind of tough to follow some of the pieces. Now, I emailed to you the spreadsheets that go with this. And if you go back and kind of search through my emails, and this has to do with the Excel mini project, search Excel and my name or something to that effect, and you'll see this file. It's an Excel file. And I think I might have sent a PDF. If not, I have a copy of that for those who need it. The big key is there are two ways you could set up this life expectancy data. You could do it with your input is the number of states, or you could do it with the second version where the input's the life expectancy and the output is the number of states. So it's hard to know which one's which, but if I go back to the original question in this the second page of the sheet, it says from the table at what life expectancy is the number of states increasing most rapidly. Just that phrasing right there is saying at what life expectancy is number of states increasing most rapidly. At what means we're talking about that as like an X or an input. Number of states increasing most rapidly. States increasing would imply that's a Y, like a rate of change. So that's kind of framing out which one would be Y and which one would be X, or which would be input and output respectively. So that's one way to look at that, setting that up. It does say look at the table above. And if you want to do, I actually have this in my Excel spreadsheet too. If you have rate of increase, or where, if we go up 1 unit of input, this is the output change, and I measure those out. And the year where it goes up the fastest, you can see that 21 in there. At an input of 71 years of life expectancy, we're seeing the number of states go to 30, and that's the biggest increase of 21. So that answers that first question. But more importantly, so that could be an answer you type in for your extra credit. But down below, I kind of put these in the wrong places. So, the place that you'd indicate is, this is the year here, highlighting above where it went up most rapidly, went up 21, and you would want to write that 21 at what life is. That's the number of states, 21 states, up 21 states or something, that increase 21 states. Anything that helps make more sense to the reader. The second piece is, part B says fit a model to it. Well, fit a model to the data and find the inflection point in the model. Well, this is, again, to find an inflection point, that means much of anything. There's two ways to graph this. I'm going to go with the second option, the one on the right-hand side. Okay, so this is what we're going to end up using, is the one on the right-hand side, because the point of inflection that happens in this one versus the point of inflection that happens in the first one, the one on the right-hand graph, the one that we're going to use, where input is life expectancy, that rate of increase, that'll help us answer part C at the end, where it says at what age is the number of states increasing most rapidly. That will follow that model where age is X and life expectancy is the number of output years. So in all those, just picking that right graph is a tough one just by the wording of it, but we're going to go with that second graph. Input life expectancy, output number of states, and the graph on the right is the one that has that. And the model that goes with it, really hard to read down, and if you're trying to zoom in on that, you want to get the file that I sent you, or try and read it from this page here, where I've written it now by hand. Ultimately, what I'm going to do with this, it says fit a model and find the inflection point of the model. Inflection point means go find the second derivative, set it equal to 0, and use any technology possible to solve it. I tend to turn to some kind of calculator, or I can use Wolfram Alpha and write solve, and then write this equation equal to 0, and it'll tell me. In any case, it happens at 70.97. So if I go look back at the graph itself, 70.97 indicates that inflection point. And we'll talk about in part C what that actually means in terms of the graph. So you want to go in part B here, find the model, write it out. So the model is this top equation. Okay, and then find the point of inflection. So you'd want to show this work. Basically, everything you see in that box, that's what you'd be showing in part B. I just put it in the wrong place. My fault. The inflection point, then you locate at x equals 70.97. Let's go to part C here. So what I'm going to do is just pause this, and I'll get the picture up for you. All right, so here's that picture. The 70.97 years of life, that's the input value x. And what the question says, use the model to find the age. That's find the age at which means age is my x. Got that part figured out, years of life. The other part is where the number of states increases most rapidly. That would be my y. Something increasing most rapidly, that would be your output. What we're going to do is then it says find also. So that part we did. I think I rewrote this. use the model that you used up above and find that age at which the number of states increases most rapidly. That's what we got in Part B or Part A. And I don't know what I was thinking, but I retyped that. So that is asking you the same question twice. And I'm sorry if that threw you off. So I'll fix that for again, I told you next semester this would be a new and improved process, but about the same thing. But that is asking the same question twice, so I just wrote it again. It says find also the corresponding number of states and the rate of change. So the corresponding number of states, just plain number of states, I'd be putting 70.97 into the y function, my original model. And so use any calculator device, use anything that could help you calculate that. And then it says find the rate of change at that place. So that'd be putting that 70.97 in the first derivative and getting that. And then the most important thing is putting the units. So if I do into the original function, that gives me the number of states, and the next one gives me states per year of life increase, because states is my output and years of life is my input unit. So it's output per 1 unit change in input. 15.29 states per 1 year of life increase. That takes care of part 2 on that graph. Now I'm going to pull up the Chipotle data next in another video and help you figure your way through that part.